Alright, so let's go through this question. So we have a gradient function of a curve, right? Varies directly with the square of x minus 2. So when you see gradient function is as square as saying dy dx. So this one is dy dx. So of course they say, oh, gradient of curve at 1, 9 is 6. So meaning the dy dx is 6. Find the coordinate of point which curve meets the y-axis. Okay, by one look, I know that this question is testing us on finding the equation of the curve. Meaning, they will, for example, they will give us, oh, dy dx. Then we need to do the integration, right, to get the equation of the curve, which is y. So that is the main thing that I see on this question, which I think not that simple lah. Okay, so maybe let's get started for this question. So first, let's do the first thing, right? So dy dx, they say it varies directly, meaning k, a bit of your direct inverse proportion, k, you put x minus 2 bracket square. Okay, so what is the next thing that we must do is actually to determine what is the value of k. The k value, obviously I use 6, I use 1 as well. So you simply just put, okay, because gradient of curve is 6, it's as good as saying dy dx is 6, is equal to k. So where is the gradient 6? It's at coordinate 1, 9. Of course, I don't need to care about 9, I just care about the 1. So this is 1. So 1 minus 2 is negative 1 bracket square. So means your k is actually just 6. Okay, so with this, I already know, oh, my dy dx is equal to 6 bracket x minus 2 bracket square. So this is my dy dx. Okay, the next thing I want to do is actually to find your equation of the curve, because eventually, right, I need to find the equation of the curve. Then after that, I want to know, when do I actually meet? Where do I actually meet the y-axis? Meaning when you see you want to meet the y-axis, this part, right, you just need to sub x equal to 0, because you are actually finding what is your y-intercept. Okay, so I do the integration. So for example, right, dy dx is equal to 6 x minus 2 bracket square. So you want go from dy dx to y, right? You integrate. So for example, 6 x minus 2 bracket square dx. So you can just put out, take out the 6. So this will give you x minus 2 bracket square dx. So integration, this one is you can see this one is just a linear function inside. So means you can actually do like that. So 6 x minus 2 bracket, so power plus 1 is 3, right? Divide by the new power. Of course, not to forget, differentiate inside. So differentiate inside is just 1, right? But of course, don't forget a plus c, because it's an indefinite integral. Indefinite integral just means there's no number right here. So you must have a c. So you do the manipulation. Eventually, you will get something like this, plus c. So this is the equation of curve. Okay, what is the last thing that we must do for them, right? Is actually to find what is the c. So how do I find the c? There's actually a reason why they give us coordinate 1, 9. So 1, 9, right? So 1, 9, sub in 9 to be here, sub in 1 to be here. So of course, 9 is equal to 2. Okay, 1 minus 2 is negative 1, right? To the power of 3. Means negative 1 to the power of 3 is equal to negative 1. Plus c. So I can eventually find what is your c. So 9 is equal to minus 2 plus c. So c is equal to 11. Okay, so almost ready. So y, so my equation of curve is y equal to 2 x minus 2 bracket to the power of 3 plus 11. Okay, so the last thing, I want to find, what is the, let me go back here. So they say, find the coordinate of point which the curve actually meets the y-axis, meaning sub x equal to 0, done already. So this one, sub x equal to 0 to find the y-intercept, right? So y is equal to sub x equal to 0. So 2, 0 minus 2 to the power of 3 plus 11. Hopefully my calculation is correct. But sometimes my calculation tends to be wrong. Negative 2 to the power of 3 is negative 8 plus 11. So this will give you negative 16 plus 11. So it's about negative 5. So since, of course, don't give them negative 5 because they want a coordinate, meaning that 0, negative 5. So that is how we actually do this question.